Question number 6, for each of the following rules, construct a table of values and draw the function's graph. Okay, we have 3 over 2 times x, y is equal to 3 over 2 times x. And I'm going to start off with x being 0. And I think for most of these that's going to be the easiest. When x is 0, then y is 0, right? 3 over 2 times 0 is 0. Then, after that, like if I pick 1, I'm going to get a fraction, and I want to avoid that. So I'm going to pick the denominator or some multiple of the denominator. Okay, so 3 halves times 2, the 2's cancel, I'm just left with 3. And then I'm going to go to, if I go to 4, then I would end up with 2 times 3 is 6, which brings us off the graph. So I'm going to go back to -2. Okay, so these don't end up in a nice row. If you like, you can go back and you can reorder these so that the x's increase. Okay, and then we just plot. So I'm going to plot my 0, 0, my 2, 3, my -2, 3, and then draw a line. Okay, for b, we have -1/4, so I'm going to use the same thing, the same strategy, 0, 0. And then I'm going to work with multiples of the denominator, right? So I'm going to use 4. So 4 times 4, they cancel, and we're left with -1. And if I use -4, we get +1. Okay, so I'm going to plot those points and then draw my line. All right, for this one, I'm going to start again with 0. And so 2 times 0 is 0 plus 1. So this one we have an initial value, right? When x is 0, y is 1. Okay, and then since I don't have any, since my a is not a fraction, I'm just going to pick values like anywhere, like the x value is anywhere between -4 and 4 and see what happens, right? So I'm going to pick 1. So if I, for example, if I pick something really big, if I pick -4, that would give me -8 plus 1 is -7, which is off the graph, okay? So I'm going to start with 1. So 2 times 1 is 2 plus 1 is 3, okay? And then if I go to 2, I get 4 plus 1 is 5, which is off the graph, so I'm going to go into my negatives, okay? And if I try -3, right, 2 times -3 is -6, plus 1 is 5 is off the graph, so maybe -2, 2 times -2 is -4, plus 1 is -3. Okay, so I'm going to plot those 3 points and then draw my line. All right, for the next one, same strategy, 0, 0. Sorry, not 0, 0. 0 times -3 is 0 plus 4 is 4, so I have 0, 4. Then I'm going to try 1. So 1 times -3 is -3 plus 4 is 1. And so I'm going to keep going in that direction. So I'm going to try 2. 2 times -3 is -6 plus 4 is -2. So I'm going to plot those 3 points, and that gives me a nice line like that. Okay, I'm going to start off with 0. So 0 times 3 halves is 0 minus 3 is -3. And then I'm going to use a denominator, like I want to use some number equal, like as a multiple of my denominator. So just to make sure I don't get fractions. So 2, and so that gives me 3 minus 3 is 0. And then, I don't know, I'm going to try 4. So 4 divided by 2 is 2, times 3 is 6. 6 minus 3 is 3. Okay, this one gets a little bit more complicated. So if I start with 0, I end up getting a third. So that's not going to work out. So I'm going to start with something that's going to give me a denominator, right? So if I start with 3, see, the problem is I want to make sure that I'm going to get something that's going to work out evenly. So you have to play with it a bit, right? So I ended up starting off with, oh yeah, sorry, I forgot to plot these points. So I started working with, I tried 3, it didn't really work. Like if you do, the 3's cancel, then you get -2 plus a third, so you end up with a fraction still. So what I was thinking is, the first one is, I want to get some positive number here, right? So I'm going to multiply it by a negative, and then I want something that's going to cause this all to be a nice whole number. So if I took -4, for example, I end up getting -8 divided by 3, so -8 thirds, positive 8 thirds, and then plus a third is 9 thirds, which is 3. Okay, so that's how I pick those numbers. -1, so I have -1 times -2 thirds gives me 2 thirds, plus a third is 3 thirds, which is 1. And then I plotted those points and drew my line, and then I found that it gave me another point. So if I took 2, that gave me, anyways, -1.